Hello everyone.
Simran, yesterday's meeting is uploaded, yesterday's session.
No, I'll upload both yesterday's and today's today.
Oh, yeah. And okay, okay.
A very good morning to all of you and welcome to today's
Not
session.
that
Simran,
audible, Simran.
Simran, are we good to start?
Yes, ma'am.
Okay. So for today we are going to do hands-on on a decision tree and a random forest classifiers and several other concepts that have been covered in the last few classes. So so we have Ashish with us, who's a senior PhD student with me at IIT Roorkee. So Ashish, I'll request you to turn on your video and share the Python code. So I will broadly walk you through the complete flow, and then Ashish will take on from there. Okay. Yeah, Ashish, welcome to the class.
Hello everyone.
Here,
I look forward for this session.
yeah. Okay. So I will just, all of you, I'll just show you through the uh, flow of the code, and then Ashish will take it up in more details. So we have already provided you a data set that relates to telco company, which may be a real or a fictitious company. The data set is hosted on Kaggle and GitHub also, and it relates to the likelihood of a telecom customer to churn or not to churn. So, so in this particular case, there are different attributes or variables. Uh, Many of these variables are actually categorical in nature, and a few of them are numeric, as you can see here. As discussed yesterday, that categorical variables cannot directly be, fed into the machine learning model. Therefore, we will need to first convert them to numeric data before doing other pre-processing steps. Like we'll also have to look at the presence of the null values, if at all they are there, or blanks and all, and then treat the data. Then we'll try to actually look at the categorical variables. So you can see here, most of the data types are written as object, and object means categorical data. And int would actually, int or float would mean numeric data types. Now we will use one hot encoding after pre-processing some of the data. Okay, there's another thing. If you can go up, Ashish. There are certain attributes that have got three values. For example, I'll show, you can see on the screen. Say, for example, multiple lines. So multiple lines refers to multiple telephone lines. So it has three values: no, yes, or no phone service at all. Just for the purpose of this particular code, we have merged the no and the no phone service. Similarly, in case of online security, we have merged the no and the no internet service, because not having online security or not having internet service anyway would lead to not having online security. So therefore, we have merged these two. Similarly, the other values where there are two no's, we have actually merged them uh, like that. Then after doing this, the data set would have certain shape depending on the number of values we have obtained. Then we are going to convert the categorical data into numeric attributes, because as we discussed, that machine learning model cannot take categorical values directly. And for this, one hot encoding will be used. Additionally, there are numeric variables also that will be discretized. So this section actually refers to the numeric attributes. And to convert these numeric attributes, we have to perform discretization or binning on the data. And equi-frequency binning has been used. We have discussed what equi-frequency binning is, that almost equal number of samples are put per bin. You can scroll down. Then what we will obtain will be the the discretized variables. Okay, scroll down slightly. Uh, then we'll go to the next would be actually having a look at what the target variable looks like. In this particular case, the class variable is churning or not churning, and it has two values, yes or no. And you can see here that the data is pretty unbalanced because not churning is there for around 73.42% of the data, and churning yes is only 26.57 or 58%. So the data distribution is a little skewed in this way. Skewed is one where one class dominates the other. In this case, it is the no class. Okay. Then I already discussed converting the categorical columns into numeric ones using one hot encoding. Details will be taken by Ashish. Uh, okay, so the discretized values, sorry, the one hot encoding would result into values, and then we'll have the data set as Ashish is showing here, and he'll take it up in more details as we go along. Then the next important thing is to build the classifier model. Now, as we discussed, to build the classifier model, the first important step is to obtain the train and the test data. Mostly in all real world applications, we have a single data set. We don't really have two data sets. So we will have to use the same data set, and we'll have to split it into two parts, which is the training and the test data. Now, the question is that when we want to do this split, then how much of data should go into training and how much should go into the test? So initially, just to illustrate, we have taken the split as 90-10, 90% of the data into training and 10% into test. The test data will be used as an unseen data to look at the performance of the classifier, and the training data will be used to train the or build the model. Now, the next thing is that after that, after making this train and the test sets, we are going to actually build a decision tree classifier. To build the decision tree, first of all, we will need to decide what depth we want the tree to go up to. Because in this case, there are a lot of attributes, and therefore we cannot use all of them. And so to decide the optimal depth, what we will do is we'll vary the depth from 1 to 29. And we stopped at 29 because the performance actually beyond that was not showing any variance. And we took the accuracy, overall accuracy of the classifier versus, just wait, yeah. So overall accuracy of the classifier plotted against the depth of the tree. And we saw that beyond a point, you could see that in the blue, you see the train accuracy, in the red color, orange color, you see the test accuracy. So training data shows a very high accuracy beyond certain points, say around a value of 6 or 7. And we can also see that on the unseen data, that is the test data, the initially the accuracy increases and beyond the value of 6. So Ashish, you can just show it with the cursor there on the graph, that beyond this value, the test accuracy started declining, or in other words, the model has started becoming overfitted. So we will accordingly choose the depth of the tree as 6, and we'll go ahead and build the classifier. The details Ashish will walk you through. Then, after having decided the depth, now we also want to have a look at whether the train test split that we had chosen, that is 90s to 10, is optimal, or whether we should also try to iterate through this. So we tried to choose different train test ratios like 80-20, starting with 60-40, 70-30, 80-20, 90-10. We obviously, there's no point having 50-50, so 60-40 is the first that could be taken. And then we tried to look at the different performance metrics like accuracy, precision, recall, F1 score, AUC, ROC. And you can see all these graphs here. And what we try to do is that we try to look at the performance, overall performance with the help of all these graphs, and try to choose that particular split that gave us the most optimal performance. If you look at all these graphs, more or less at a split of 80-20, which details Ashish will be taking you through. Ashish, you can show with the help of your cursor on the plot that around 80% of the training data, you can see that the performance is more or less uh, quite optimized. So we will go ahead and choose 80-20 as the best split, and accordingly we will uh, build our final decision tree, right, with 80-20 as the split and the depth of the tree as 6. And then we will calculate the different performance metrics again to have the final performance which you are seeing here, right? For example, the accuracy and other metrics come out as, accuracy comes out as 79.38% and so on and so forth. Then after having done all this, we will also visualize the decision tree. This will give you an idea of how the splitting is working. And remember, all this is being done with the help of entropy. So using entropy as the metric to decide which attribute to choose to do the split. Then after having built the tree, the details of which Ashish will take, that we just showed how the tree is doing a prediction on some of the test samples, which is the next part of it, just as an illustration. So this is building the tree with the help of entropy with a depth of 6 and a split of 80-20. Now we'll also illustrate the tree and we'll repeat all the steps using Gini index. So everything will be the same, only instead of entropy, Gini will be used as the criteria to decide which split to use. And then we'll find out the performance. The performance comes out to be a little better using Gini. And then again, the decision tree also has been plotted here with the help of the Gini index out here. Okay. So we are done with the formation of the decision tree. Now we'll come to the random forest. So as we already discussed, that random forest is a collection of random number of trees. So this is a hyperparameter to this particular process. And therefore, we first try to decide how many trees we would want to use in the random forest. And we try to vary the default value is 100. We try to vary it lesser and greater than the 100 value, which is default in the function. And we try to look at all of the performance metrics like accuracy, precision, recall, and all, again with the help of the graphs. So you can see here that you can show with the cursor, Ashish, that while we try to look at it, the best performance is coming for most of the parameters with the value of number of trees as 150. So we will choose the number of trees to be 150 for our random forest. Okay. Then after that, we will decide uh, the number of features that we want to keep. So remember that randomization in the random tree comes from in two ways. One, deciding the number of trees in the decision in the random forest. Second is deciding how many features to use. So we also try to iterate on this hyperparameter, that is the number of trees, and we chose it in the range of 5 to 29. And then we again found out the performance, and we could see that pretty much the performance was coming out to be most optimal. You can show with the cursor at around a value of 15. So most of the parameters were working best at the value of 15. Some variances in the local values would be there, but however, more or less 15 was the best and optimal value. We chose 15 as the value for the number of parameters. And then we built the random forest. The split we chose is 80-20, which already we have decided based on this particular data and our earlier experiments. So we built the tree using all these hyperparameters, and then we found out the performance. And when we did a performance comparative of the random forest versus the decision tree, maybe you can scroll down a little. So we found out, and then the decision again, the random forest was also built using entropy as the splitting criteria, and also as Gini using the splitting criteria. Both of them were used as we had used earlier also in a decision tree. And then we found out that the best performance was coming out with random forest and Gini, with the other hyperparameters remaining the same, that is 6 depth, 80-20 split ratio, 150 as the number of trees, and 15 as the number of as the number of attributes. So I think this is pretty much it. This was the broad flow of what we are going to discuss. So I'll request Ashish now before to take the code in details. Before that, if there are any questions on broadly on the flow, maybe you all can ask.
Ma'am, for decision trees, we don't like. Is it necessary or compulsory to do that one-hot encoding, or it would still work with decision trees if we don't?
So if the attributes are categorical, then in that case, actually what will happen is that even if there may be some numbers, but they will be taken as numbers. It might work. Let's say that if, for example, in the attribute like senior citizen, the values are 0, 1, which look like numbers here. I think Ashish is also showing with the help of the cursor. So though they are numbers and it would work, but actually the model will be treating them as numbers only, and it doesn't really know that these are categories. So treating categories as a number and then using entropy on it will actually result into a wrong, performance, or the tree will not be built properly. The tree will be built, but it wouldn't be giving you the results which are actually correct. So therefore, we would want to first convert explicitly the categorical attributes into numbers. Even if there were numbers, but if they are categorical, then they are not numeric types, then we need to convert. Numeric attributes we need to discretize. Okay.
Okay, ma'am, got it.
So I think Ashish, you can take over from here and start with the detailed discussion on the code.
Uh,
I'm done for myself.
Ma'am Sumitra here. So, ma'am, can
Yeah.
we say for decision to making decision table, we have to have categorical data type?
So it is true that for making a decision tree, you need discretized data or categorical data, right? Actually, categorical data, or you can see that it should be there in form of categorical data is required, but it should be represented as numbers,
Okay.
because the categories cannot be understood directly by the computer system. Neither the analog values like continuous valued ranges. I think some of the attributes, if you can go down, Ashish, a little, you are having the features out there. For example, the monthly charges or something. So you can see that there is tenure and monthly charges, which are
Mhm.
numeric types. So they can take an infinite range of values. So we have to discretize those. And those which are categorical, we have to convert them into, they remain they do have categorical meaning only, but for the purpose of the computer system to understand, or the ML model, we have to represent it in some numeric vector. Okay.
Yeah. Got it. Thank you.
Yeah. So I think more details you can ask as we go along in the code. So without spending more time, Ashish, you can take over.
Good morning, everyone. So we begin with the Collab notebook. I hope everyone has the access to the notebook and the dataset. So we are working today on a telco customer churn dataset.
Uh,
With
just a second, sorry to interrupt, Ashish. I hope everyone has loaded the file and there are no issues because I could see some.
I think
not able
access
to.
you need to grant the access first.
Yes.
It says someone has to grant the access.
Which one? Loading of the
Page
file you're saying?
loading of the page
Yes.
itself.
Yes.
Uh, Loading of the page, where are you talking about Colab?
Yes, ma'am. Collab.
Actually,
So I
ma'am, it
think
is
that
in
is,
Google Drive and it is asking for that permission.
oh, the files are on Drive, you're saying?
okay, I think
Ashish, have you put them on? No, I attached the files and gave.
yeah, but I think we have given you a separate collab notebooks.
It was shared yesterday, I guess, the files.
No, I think they are talking about Simran. Have the files been put on Drive for which access is required?
Ma'am, somebody has shared it on the chat, Suresh. So they are trying to access that actually. So that is not
Oh,
possible.
No,
So they,
I've directly uploaded on LMS. You don't need any drive access for
correct,
it.
yes.
You can go to the LMS under module 2, week 6. You'll be able to find.
Yeah. Please don't access this Suresh links because Suresh has to approve for everyone then.
Hmm.
Because you are trying to access Suresh Google Drive.
okay.
That is not
That was the
required.
issue.
Yeah, yeah. You
So,
have to open their lab and then go ahead. Yeah.
yeah, so
Because-
I'll give you 2 minutes, everyone, to quickly please load the files because we'll start the discussion and then you'll be only struggling to load. So Ashish, just will allow 2 minutes for them.
Where can I get where can we get that?
In the
Because
lab material.
module two, in module two, I didn't get any lab access related data.
No, Shayok, there is a lab material folded in the module too. Like Simran just mentioned, right? They would be able to download it directly. The whole folder about today's hands-on.
Anyone able to upload it to the Google Colab?
Simran,
Is it
Simran,
readable?
Simran, can you please provide the path
So
in chat?
guys, go on to your LMS. Module 2 is there. Under module 2, week 6, there's lab materials, but I'll also provide you with the path in the chat.
Okay, lab material. Okay, got it. Yeah, got it.
So I hope everyone is now ready. And Ashish, I request you to please start.
So today we are trying to work on telco customer churn dataset. It's a dataset about a fictional telecom company, and the objective here is to predict whether a customer will churn. By churn, we mean whether they will leave the service or not based on their demographic, service usage, and account details information. We've shared links, original links of the dataset. Am I audible?
Yes, Ashish,
Yeah.
please go
Okay,
ahead.
okay. So we have shared the Kaggle repository link and GitHub CSV file also if someone wants to separately download the dataset. So the target variable in this dataset is churn, which is a binary variable of values yes and no, whether the customer has churned or not. There are a good number of there are total 21 features in this dataset. So there are features like customer ID, which is a unique customer identifier. Then there is gender, senior citizen, partner. So there are all these in this table. I have mentioned all the various columns, the features of this data set, and most of these are categorical with values like yes and no, And like ma'am told earlier, some have three category value: yes, no, no phone service. Like interest net service has DSL, fiber optic, no. So there are like this, there are various categories in some variable, and in some variable there are only two categories. Apart from this, there are three numeric variables which are having numbers, which is tenure, which is numeric. Then there is monthly charges, and there is total charges. And to be cautioned with, I have written here that float needs cleaning, because in total charges there are some missing values. We will see later. We will see later how to identify these missing values. Okay, so these are the Python packages used in this notebook. So we will have, as usual, a pandas package to load that CSV file, manipulate that, and load it in a data frame, manipulate the data set. We have the matplot to visualize and plot graphs. We have the scikit-learn, which is our go-to package for machine learning, building machine learning models, for doing data pre-processing. And within scikit-learn, there are specific modules which have been used in today's notebook. So I have mentioned them all. Like we are doing the discretization using pre-processing module. We are doing train test split using model selection. We are the decision tree classifier lies in the tree module of the sklearn. Random forest lies inside the ensemble module. And the various metrics which we'll use, they are also, like, we don't have to write the functions for each metrics. They are already there. So in the metrics module, we have these functions for accuracy, precision, recall, etc. And last package is NumPy, which is used for doing mathematical operations on data frame, and during plotting and during model evaluation. It's mainly used for doing mathematical operations. Like I have, if somebody is working on their system locally, they can install these packages with these commands, or either they can uncomment this block and install all of them at once. But in Google Colab, all of these come pre-installed. So the first line is to load the data set. So this is how the overall, when I load the CSV file, this is how it looks in a pandas data frame. There are 7043 rows and 21 columns. In total, there are 20 columns, and one is the target, and one column is the target variable. So the last variable churn, it's the target variable. And apart from there are 20 columns. In total, 21. Okay, so customer ID, it's not that important column. It's just a identifier. So ultimately, when we'll do the evaluation and all, we will first drop the customer ID column. And okay, so we move further and we look at the data types of some information about the data types of these data frame. So when I do a info on the data frame, the name of my data frame is DF here. So I see that I get some information about the how many columns are there, non-null values there. So it seems on the face of it that there are no missing values here. The first observation is that there seems that there is no missing value. But the problem is the total charges. It was to be a numeric variable, but the pandas is storing it as an object data type. So there arises suspicion why it is doing so. So I have we have found it previously, so we are just stating it. What's the reason that after doing the investigation? So the thing is, there are around 11 columns where total charges is blank. There is no.
You are breaking.
Is my voice breaking?
No, it's clear.
Yeah,
It's clear for me.
Okay.
Yes, clear.
So there are around 11 columns where total charges value has no value. It is leaving blank. So I have printed these values. So that's why it has stored these as it's treating the total charges as a string value, and it's storing as an object. So what we will be doing is we'll remove all these 11 columns, because we don't want, we could have filled with missing values, but for simplicity, we just dropped these 11 columns for further analysis. Now, after, wait a minute. So after dropping them from 7043, we are to 7032. Next,
Just I wanted to comment. These are rows. I think you said columns.
yeah. Okay. From 7043 rows, we are now rows or samples. We are now to 7032 samples. So one more observation I want to point out: the senior citizen column, like we told, it's a categorical variable with values 0 and 1. But since it was 0 and 1 values, pandas thought that it's a integer variable. But we know the 0 and 1, these indicate categories, and these indicate categories. So what we did was we changed the data type of senior citizen to make it an object data type, to be consistent. Now in our data frame, when we print the data frame, df info again. So whatever is an object data type, these are all our we can refer to them as a categorical columns, and whatever are integer and float, these are our numerical columns. So I saved them in separate variable for analysis, and like we have 3 numerical columns and 18 categorical columns. Now, as ma'am mentioned earlier, that for multiple columns, there are like redundant no's. Like there is for this column multiple line, there is a no here, and there is a no phone service. And like that for many of the columns, no internet service and no, and or no phone service or no. So since these are, since the no already implies this no phone service is implied in this no. So for this redundant information and to lower the split, we merge these to avoid any further redundancies. So after merging no with no phone service or no internet service, we see for these columns, now there are only 2 categories, no yes for all of these categories. Next, there are, as we said, there are 3 numeric columns: tenure, monthly charge, total charge. What we did was, since these are numeric columns, we discretized them. We tried to make categories out of them. How? We use equisequencing method, where we will split the data into groups or bins. And for each bin, there will be, or group, there will be equal number of data points. We selected 4 so that in each group, there will be roughly 25% of the data. And each group will have a number, like from 0 to 3, there will be assigned a number. So initially, tenure, monthly charges, and total charges, they looked like this. They were numbers. Then when we discretize them, so in in scikit-learn, there is a particular function for this called k-bins discretizer. We give it n bins 4. Like you can try for 5 bins also, or less bins also 3 for experiment. And we are telling it to have an ordinal encoding. So ordinal encoding, we mean that we want to give numbers to group like 0, 1, 2, 3, like that. And the strategy here, the equifrequency binning, the name of that strategy is called quantile here in sklearn. So after we do this, each of this, we created new columns. So tenure bin, monthly charge bin. So every one of this column now lies in one of the groups 0 to 3. Now, since we want to work with all of the categorical variables, now we have created even the numeric attributes as categorical. We'll create a new data frame where we'll drop these original numeric attributes, because for further analysis we will use the discretized version. So after removing the numeric attributes, so this is how.
Ashish, I have one question here. When you discretizing, right, are you checking the rank order also? Because these variables, say, for example, if I look at tenure, right?
Yeah.
If a tenure is high, then attrition would be lower. Something like it follows some rank order?
No, it right now doesn't follow rank order. Like if there are the ranges from 0 to 100.
But there should be some trend, right? Monotonic trend, whether increasing, decreasing, right? With respect to tenure, charges, those kind of things. Hello.
Ashish
Sir,
is not audible.
actually, it's there are thunderstorms today. So I'll just call him. In the meantime, right now the primary focus was to build classifier only, but it's a good idea. We can try to also explore whether there are some relationships or not, and that can be done in different ways. Uh, I think Ashish has just got logged out. Let me just call him. Give me a second. Probably due to a lot of rain and thunderstorms here. Allow.
Am
Yeah,
I
hi
audible?
Ashish. Yes, yes.
Yeah.
Okay, you are audible now.
So what I was saying is uh, the ordering, the rank ordering is just for identification purpose here. It does not have meaning for our particular case, because ultimately we will be one hot encoding all of these variables. So that's why we did not give so much focusing to rank ordering right now.
No, that I got it. It's fine.
Okay.
Thank you.
So after discretizing everything, so the DF2, now we are working on the data frame DF2. It looks like this DF2, and these are my discretized versions of the numeric database, which I have identified with tenure bin, monthly charges bin.
Ashish, sorry to cut you. Just one thing, can you repeat? Why did you change the senior citizen category to an object? I mean, what was the reason?
Senior citizen. Okay,
Yeah,
so
yeah.
basically for consistency, basically it was the original value in senior citizen was 0 and 1, but
Acha, okay.
these are categories.
Fine, fine.
If we treat them as numbers, the model might identify them numbers. So we want to have treat them as categories only. Like these
Got
numbers as such don't have meaning. They have meaning only in the form of, like, we want to identify for grouping. Like it's a 0 group, it's a 1 group. So that's why we converted it.
And one thing, this total charges, you have dropped those 11 columns. Could we have added them with zero charges, or it would made any sense?
Yeah, if we added with zero charges, then like we could have explored it, but it might influence the model in a negative way. So for simplicity right now, we dropped it, but we could I will encourage everyone to try, like in the previous classes we discussed some missing values imputation strategies. If we worked with if you use them, maybe we can get a better accuracy or other metrics by doing that. But for simplicity here, I dropped them.
Ashish, Sumitra followed to this one. So we have here like 11 column, right? So we can find out by seeing that this is the numeric one, the citizen, and you try to convert that to category. But if it is having a, a large bunk, then how do we find out like which
Somebody
So I
else.
request people to switch off their microphones. Another thing is that I think after doing some part of this attribute pre-processing, then we will be taking questions for better flow. But I think Ashish, you can first respond to Sumitra's query, and then we'll complete some part. I will invite questions. So I'll request you to note down your questions, and then we'll invite. Okay, Ashish, please carry on.
So Sumitra, can you once again ask your question,
So
because
here, like we have 10 rows, right? So we find
yeah.
out that the senior citizen number is having the numeric. So my question is, instead of 11, if could have n number, which is like a large bulk, then how do we first find out like which are the row we are having the numeric data?
Okay, so I think you are confusing two things. The column which I dropped is total charges. It was senior citizen different. I did not drop anything from senior citizen. I just changed it like data type from integer to object.
Yeah,
It's
for the integer
okay.
type only. Let's suppose senior citizen is having integer, right? So how do
Yeah.
we? This is now visible, and we can find out. Okay, senior citizen is having integer, and then we can try to change this one. But if it is a bulk one, then do we have a way first to find out like which are is having integer and then to convert?
Like, okay, by
So
bulk, what do you mean by
Sumitra,
bulk here?
I will address this. Sumitra, how you actually, I think your question is that there can be many such attributes, then how to cater to them. Is that what you are asking?
Yes, ma'am. So right now this data type
Yeah.
is integer, but it's visible. But if it is a
Okay,
huge number
okay.
of
Oh,
data, then how do
yeah.
we find out that, and then we can go ahead?
So here, yeah, you can just stay here, Ashish. By doing finding out when you do a dot info, you come to know what are the different types of the attributes. So you get a list of the attributes and their data types. As you can see here, right, that you have 21 attributes and you have 2 to 3 categories. One is the object type, one is the integer, one is the float. Now you already know, especially in this case, that you do need object type only because this object type you will be actually converting into using one hot encoding. Now, if there is any data which is having some type such as this int type you are seeing here or a
Mhm.
float type, then what you will need to do is explore it further. So once you see that senior citizen is int type, so we all know that senior citizen, this particular column, when you look at the values, you will see only two values, 0 or 1. 1 meaning obviously the person is a senior citizen, 0 meaning not a senior citizen. So by doing this analysis, you will come to know, just you can have a look at the columns which are showing integer types. See, you can
Mhm.
see that. I think you can come back to those to the values. I think you had done yeah. So if you do a dot head or anything, you will
Mhm.
see that these are having only two values.
Okay.
Obviously, having 0 or 1 doesn't mean it's a number. It's definitely a category only, right? So you will have
Yes.
to explicitly convert it to a category type. Otherwise, by default, something looking like a number is taken as a number by the model. And if it is taken like a number, then it takes it like a number 0 and 1, which is not correct, right? Now, the other attribute, which is numeric type, is this one, which is your monthly charges. Now,
Mhm.
if you and total charges is object type. So, monthly charges, first of all, if you look at the monthly charges, values in it take up any value in the range. So, for example, here you can see monthly charge look like 105, 29, something, some value. So this is actually a number. So it is indicated as a number and it's actually a number. Now you remember that the decision tree works on categories. So we'll have to convert it to categories or we'll have to discretize it because these are numbers. So they have to be put into bins. So some form of binning is to be used. We discussed discretization earlier and
Right.
equi-frequency discretization is being used here. Then the next thing is total charges. You can see the total charges is actually a number. You can see here. But
Right.
in that dot info, you are seeing it as an object type. So this is a little contradicting because it's a number, it's looking like object type. And I think Ashish already told you that some of the values in some of the rows contain blanks. So on the basis of those values, it is actually inferring that it is an object type, but it is not object. It is not a category. Object type means categorical data. So it is a number. So it has to be actually treated as a number. And then because it's a number, it needs to be either categorized or the missing values need to be treated. In this case, we have just ignored total charges for further analysis, but you can add it also and do.
Got it, ma'am.
Is it okay? Yeah.
Thank you. Got it.
Yeah. So Ashish, you can continue, and
Okay.
once we are done with the pre-processing, then we'll take the rest of the questions before loading the data and doing further thing. Yeah, please
Okay.
carry on.
So just to add that every dataset, it comes with a dataset card. If it's a standard data set. So from the initial information of data set, we knew that for each column, what is their categories. And when we loaded it in pandas, that was conflicting. Because from the initial information, I knew that total charge was an integer, it's a numeric data type, but it was loading it in an object. So that created suspicion, and which we further investigated to find out that there are some black values. So, okay, we'll continue further. Okay, so we were now on DF2, where we had which is same as DF1, but we removed the numeric attributes and used their binned version, their discretized versions. So now we see that all of these all our columns are now object data type or the categorical data type. Next, we see the we show the target. Next, we show the target variable count plot, which is churn. It's hugely imbalanced data set, and real life data sets are imbalanced. That's why we worked on it, despite we'll see later the performance is slightly on lower side. But in real life data set, usually you don't have a good situation of balancing. So here, the yes situation, when the person will leave. In this data set, only 26% users are such that are indicating churning. Otherwise, 73% are indicating non-churning. So this is important because this will impact the performance later on. And next, when we are now in the data, so we have done some pre-processing, very little bit of EDA, and now we'll prepare the data for our models. So for data preparation, we need to have separate X and Y. By X, I mean input features. By Y, I mean the target variable or the output variable.
So Ashish, just sorry to interrupt. So one thing I want to show, because the focus was on classification, hence little or almost very small amount of EDA is included here. You all can do for sake of interest, because if we add EDA, then we lose out on, the focus on classification. That is one thing. Second thing is, up to now, we just prepared the data, and then we are going to start actually with the process of preparing the test and training data. So any questions, anyone so far? So that everything is clear from now on. If there are any questions, please, you may feel free to ask.
Yeah, Ashish, I have a question. Like when we are doing discretization of total charges and creating equal pinning, so I mean, can't we go directly with the numerical number only?
Like we can go with numerical numbers, but decision tree implicitly it also discretizes in its algorithm. The decision tree algorithm is such that it works on thresholds only. So it implicitly also discretizes. So to make the calculation simpler, we gave it a discretized version beforehand.
Just I want to add here, actually decision tree algorithm requires, categorical data only. Now, if we had to actually code a decision tree from scratch, then what we would have to give it is categorical data only. Now, in this case, we are having a library function which helps us to actually build the tree by only looking at the hyperparameter tuning and all that stuff. So in that particular pre-coded tree, if somebody, or if the coder overlooks converting the numeric data into categorical, then by default, that function will do it for us, right? So even if you give it that data, it will do. But actually, but those will be default values and they would not be as per our requirements. So we have explicitly done this uh, in a better way, like that.
Okay.
Is it okay?
Yeah, yeah.
Any other questions, anyone?
Ma'am,
Before we
when we
proceed?
did binning, then does Just does 0 means some limit to some, and 1 means from this range to some value. Is that what it means, right? Or it's a
Yes.
mean of values in that bin, uh, or it is doing everything by its own?
Ashish, you can please take
So,
it. You can show the range.
so it's like if you have numbers from 0 to 100, the first 25% numbers will be in bin 0. The next 25% numbers will be in bin 1, and so on. So
And
these are just numbers to indicate the group to which they belong to.
and they are first sorted, then
Yeah,
divided into
quantile
groups.
strategy is
Okay, okay.
on that only. Everything is first sorted in increasing order, and then we split them into groups.
Okay.
So I have a question here, like for all the classifier, whether it is a random classifier, random forest, or decision tree, or let's say if we think about logistic, should we, I mean, it always takes categories only, right? So total charges and all should be discretized in that case, right? For logistic also.
Now it depends because today we are dealing with decision tree. We discretized that numeric value attributes also, but logistic regression itself works good for uh, uh, numeric attributes. In that case, in that situation, you would have to deal with how to handle categorical ones. Right now, because decision tree is more favorable to categorical variables, we modified the numeric attributes to look more like categories. In logistic regression, we would have to go the other way around. We would have to make the categorical variables look like more toward like numbers.
Okay.
So this class is primarily focused on handling data and working on the decision tree and random forest, which is also another variant. So hence we are actually dealing it like that. Any other questions, anyone?
Yes, I have one question. It might be a naive question, but I got confused between discretizing a numeric data and why we are then cat converting a categorical data into some numbers using hot encoding, one hot encoding. So these two conflicting methodologies just confuses me.
Okay, so right now we have not in the code flow. I have not shown the one hot encoding part. Till now, we have just like done a ordinal encoding. So I think you are aware. You are aware of ordinal encoding. We are just giving numbers for every variable. There are just numbers right now, or categories. One hot encoding I have not done till now. So like we I will address your one hot encoding part once I go to that column. I will to that code block. I will address why we need one hot encoding.
Sure. Thank you.
Okay.
Any other
Ma'am,
question?
yeah, one quick question, ma'am.
Yeah,
As we
yeah.
understand, like decision tree does not work well with imbalanced data. So, are there any techniques which we should apply to handle these scenarios?
Yes, yes. Uh, Ashish, just I'll
Okay.
quickly, yeah. So here we have not actually, you know, done anything on that. So there are techniques like to treat the imbalanced data. We have oversampling and undersampling. Uh, in oversampling, we try to increase the number of samples of the minority class. In undersampling, we try to decrease the number of samples of the majority class. So for now, since I had not discussed this, so we have not included in some of the consequent discussions on classifiers. I'll show it to you. As of now, I wanted you to also see how, what is the performance like on the original raw data. Okay.
Okay, thank you.
Okay. So we are good to go.
Yes, sir.
Okay. So till now, everything has been converted into categories, and there is only one column for each category. And and each column can have like if like senior citizen has two categories 0 and 1, partner has two categories yes and no, internet service has I think three categories, DSL, fiber optic, and one more. So like this, so every column is a categorical one. Like tenure bin has like four categories from 0 to 3. Okay, so uh, the next thing is in the decision tree. So now we will okay. So now we will do the one hot encoding uh, on our input features. First, we separate the input feature. So everything in this columns, everything apart from churn is our input feature. We I think I skipped a line. Okay, so we dropped this customer ID because it was not useful for us. Apart from this, now every other column apart from apart from churn. Can I see the churn here? Apart from this churn column, everything else is our input feature. So the X here, it's the input feature. We just remove the churn column from it, and we called Y as the churn column. The Y, it's churn, it's Y for us. And since they were in yes and no, so we first mapped them to 1 and 0 before signing into Y. Now what happens is the X look like this. There are 19 columns, 7032 rows in it. So the thing is to have a now we did one hot encoding of each of these categorical variables, because to have a better interpretation of what decision tree rules are. We did this one hot encoding. We'll just see. So this was this was okay. So this was the original data set. After one hot encoding, the data set looks like this. So you can see now the columns have increased. So how they increase this, like what one hot encoding does is it binarizes every column. So if a column has two entries, like senior citizen had 0 and 1, it will make, if a column has n entries, it will make n minus 1 columns uh, and a binary column for each. So there is a column gender male now. So where it is false, it all implies that it is female. Where it is true, it's male. But a column like internet service, it had three categories. So there will for it there will be two separate columns created. So here for internet service, there's a fiber optic, there is a internet service no. When both of them are no, it implies no. It implies DSL. It implies DSL. So this is how we now created binary attributes for all of them. So decision tree, the interpretation of decision tree. So the usefulness of decision tree is that it is highly interpretable model. You can just see the rules by plotting the decision tree, how it is deciding for an input sample. So the usefulness comes when everything is a binary column. When every input column is a binary one, whether it can be true or false, then its usefulness is the most optimum. Otherwise, what will happen is, suppose I had this internet service column had three values, 0, 1, and 2, like that. So what the algorithm will do is it will split on 1.5. Now 1.5 as such has no meaning right now, because we had 0, 1, and 2. So what do we mean by 1.5? Whether to go to 0 and 1 only in left, or whether to go to 2 in the right. But if we have exactly a binary column, so I'm moving to decision tree to show.
అదే ఏదో చెప్తున్నాడు, కామన్ బాత్రూమ్ లో ఫ్లష్ పని చేయట్లేదు ఫస్ట్ నుంచి, మనం ఇచ్చినప్పటి నుంచే.
Venkat, please mute yourself.
So now, since I had created everyone as a binary column, the meanings are very clear. For less than 0.5, we mean we are going the value 0. For greater than 0.5, we mean it's 1. But suppose it had three values, 0, 1, and 2. And the split was decided on 1.5, because anyways, the algorithm will decide some split on some of any number. So it is not intuitive. It's not meaningful what that would mean. That's why we converted each of the column into one hot encoding to get a binarized attribute for everything. I hope it clears the doubt regarding what was one hot encoding, why we need one hot encoding. Shall I proceed further?
Yeah.
Ashish, can you
Okay.
explain again, please?
So I was saying that before I did one-hot encoding, this was how the axis, the original axis look. This is the input features. Okay. So these are 19 columns, and the 20th column is my churn. I have separated it out. So the problem here is it in each column there are all the categories are inside each column. So in gender there are two categories, male and female. In senior citizen also there are two categories. But some column there are more than two categories, like internet service. It is having three categories: DSL, fiber optic, and no. Similarly, our tenure, our tenure bin, it is having four numbers, 0, 1, 2, 3. So the problem is, that the split which will happen, to make it intuitive, because decision trees usually preferred to have an interpretable prediction, because you can like you can plot the tree like I'll show it further also. So there is intuitive rules that you can see how it performed. So in order to have that thing, what we did was we did one hot encoding of each column. Now what one hot encoding does is, for each column, if there are suppose for this column there are three entries, it will make two separate columns, and where each column will have a binary value, the presence of it or not. So like internet service, fiber optic, this means whether the fiber optic is present in the sample, in the sample or not. Internet service, no, it means whether this is present in it or not. When both of them are false, it indicates DSL. So if there are n columns, there will be n minus 1 binary attributes created for that categorical variable. So that's why we did one hot encoding.
So Ashish, you're doing this because you want to accommodate this data into your binary tree, right? That's why you're doing this, right?
Yeah.
Okay.
That's why. Otherwise, we could have for use without that also, but the tree would would not be meaningful.
Ashish, one question, Shikha here. Tell me if every column would have just two values, just like we have in gender or
Yeah.
senior citizen, just false true. Then also this one hot coding was required.
So in that case, one hot encoding is similar to what was original. So like if there were only two columns, so one hot encoding created only one variable. So
Okay.
in that case, it is equivalent to the original
So
thing.
then it was not required, right? It is only if we have more than two categories.
Yeah.
Okay, thank you.
And also, Ashish, one question. We are dropping one column, right? That internet service underscore DSL.
We are not dropping it.
We are not considering because
because it can be inferred if both of these are false. It is inferred that internet service is DSL.
So what if a customer has bought two services? Then don't we need the values for each of the attributes?
I think in this dataset there is exclusive one out of three. The customer uses one only. I don't think there are like two of them in any one.
These are mutually exclusive categories
Yeah.
in the dataset itself.
Okay.
Now that's why it's working in the dataset. Otherwise, it would be conflicting.
Okay.
Thank you for pointing it out. Okay, so now finally, after creating this one hot encoded, the columns have increased and everything. So now there are 29 columns. On this, we will do the further analysis, or we'll train a decision tree. I do a train test split. Initially, I took a 90-10 split. The test size is 90. The test size is 10%. Train size is 90%. And this is how is the shape which will look. There are around 6,000 samples in train data set, train set, and 700 in test set. So now, when we do a decision tree classifier, the first most important thing is the depth of the tree. When to stop the tree? Like it's a most, and we don't know it beforehand. We always have to try and look at various numbers. So in this code, we tried to search for that thing only. And it also shows us the case of overfitting and underfitting. By doing a depth search of the tree, we are also able to see overfitting and underfitting scenario. So we see when depth, the train accuracy, it goes on increasing with the number of depth. But the test accuracy, it peaks at some value, then it goes on decreasing. So that means after a point, the model starts to overfit. It tries to learn all. It tries to learn. It tries to memorize the entire data set instead of learning any pattern, because it is now performing very poorly on the unseen test set. So even in numbers, we can see that the test accuracy, it increases up to a bit at 784 and then start decreasing. Like I have chosen 784, but we can try on 5, 7, like some nearby values also, and see if we could get any gain from that. So by doing this, we fix our depth size as 6.
Just wanted to add here, Ashish. Sorry to interrupt. So, as already explained to you, that when the accuracy on the training set increases, but on the test set decreases, it means that the model is getting overly fitted, or it's very specific only for the training data. As a result, the accuracy is increasing in a very steep fashion, whereas the test accuracy is decreasing, as you can see here. So this beyond the value of depth of the tree of around 6, this is happening. But before this, maybe you can show, Ashish, with the help of your cursor, prior to value of 6, what you are seeing here is that initially the value of the training error and the test error with values of tree depth less than 6, both are, accuracy is low. So this means that when the accuracy is very low, for the training data also, it means that the model has actually not yet even learned the training data. It is yet to learn the data, and it is still very specific. It's not even, done with the complete learning of the training data. That is about the train accuracy. The test accuracy here is also low because the model, since it has not learned the entire training data, therefore, prediction on the test data is also very bad. So you can show with the help of your cursor that at values like 1, 2 and all, with the depth of the tree is actually not being built to the extent which is required, and therefore the accuracy is low both in case of training and test error, training and test data, and therefore this is the case of underfitting. So we don't want underfitting, we don't want overfitting, we just want the optimal balance, and that's is value around 6. As you can see that the training accuracy is highest at tree depth of 6, and uh, the train accuracy is also high at that point. So we chose that as the depth. And also, I think we have not included it here because the code was already becoming long. Just to illustrate, you all can try on your own. If you go on increasing the depth beyond 6, you will find that the performance of the final model will decline. So we tried also before finalizing on 6. However, you all can try as an exercise. You can try on your own. Okay, Ashish, I think you can take on from here.
And ma'am, here accuracy is that accuracy and recall that you told us, right?
Yes,
Yeah,
yes,
okay.
exactly. So this is the accuracy means true positive plus true negative divided by sum total of all, which is true positive plus true negative plus false positive plus false negative. So this is the overall of the model on all samples.
Thank you, ma'am.
Yeah, fine.
Okay, so once we settled on the tree depth, we find like 6 to be working. Like as ma'am told, we can try on different depth also. So the code is here. If you want to try at your own, we just change this depth to a certain number. You can try like 9, 10, 15 or whatever. So now we move on to further. So first, now we are settled with the depth thing. we'll see the impact of train test ratio on decision tree performance. So we arbitrarily fixed, like we know that we want to have that we want to set a good number of portion of the data as a training set, but the choice of 90% of the data set is as such arbitrary. We want to see if there are some more good ratio of the training test split which we can use. So for that, in this section, wait a minute, let me run it. Okay. So in this section, we see the impact of various metrics when we vary the train test split ratio. And
one thing I have to add here, Ashish, can you please come to state part? So I think there was a question in some of the classes earlier they had asked. There is a value random state. Can you come to that in your?
Okay.
So actually, even if you have data,
Your voice is breaking.
Your voice is breaking, man.
okay, so let me just off my video. Is it better now? Shall I? Is it better?
No, ma'am.
It's still
No.
breaking.
It's still breaking.
It's still okay. Try to connect. Ashish, you can continue explaining what you I will come to this random state and stratify later. Please carry on. I'll come back to all of you.
Okay. So we were on to see the impact of how train test ratio impacts decision tree performance.
Sorry to interrupt you. Can you explain this underfitting and overfitting graph once again?
Okay. So what happens is underfitting means that model has not learned anything. Like it is not even able to learn the train set. By underfitting we mean that even the model performs poorly on training set also. And in training set we have given it both x's and y's. We had given both things, but it is even not able to learn that. By that we mean underfitting. So in the underfitting regime, both performance on both test set, which is the unseen data set, and on train set is low. But when the model starts to learn, there is now the phase when model starts to learn. At least it's trying to learn good on its performance on train set is improving a bit. But then what happens with more increase in depth? It starts to learn too much. It tries to realize too much on train set, and it's like it's trying to memorize the train set totally. So that's the regime of overfitting. Now model has learned is highly dependent. It's learned the pattern of train set so much that when it sees the test set, it again starts to see a decline in performance. So what usually happens is the train and initially in the underfitting regime, the train and test performance both are low. Then they increase. Then they increase together. But after a point, when the overfitting starts, the test set accuracy starts to get lower, but train set accuracy keeps on increasing, and it will reach to, like, it has saturated around 95%, and it can even reach to 100% there. But we know that the accuracy on train set does not mean much because we already gave it y. We already gave it x's and y. But in test set, the main metric we want is focus is on test set because we had not given it y. What is the correct ground truth? So this is the difference.
I got it.
hope you got it.
Yeah, thank you. Yeah.
So we wait, Tushar, we can wait 2-3 minutes. I finish this block, then we can take your question.
Yeah, sure.
So this is the now we are seeing the impact of train test ratio. Okay, so this is how the graph looks. We see at different ratios 60, 70, 80, and 90. How the train accuracy and test accuracy varies, the precision varies, the recall varies, the F1 score varies, and the AUC varies. Now it becomes there is no single split which performs well on everyone. Like we can like if there comes out a single split ratio which performs well on all metrics, it's good. But since it's an imbalanced data set, we'll see that like 80 is performing best on accuracy, the 80 ratio. It's like around second best on precision. Then it's second best on recall. It's the best on F1 and on AUC. Like the performance is decreasing with the increasing split, but still like as a trade-off, because at least we want like 80% of the data. Like we can't like AUC is very performing very good on 60%, but 60% of the training set, taking only 60% of training set is very less. So in order to like balance everything, we use 80% as our train set size from these performance. Like for experiment, like for exploration, we could have tried for. I tried for other things. It was not doing good, the performance. Like you people can also try on other ratios. You just have to like give a number here. Like it's pointed, set here pointed. You can set it to 0.6, 0.7, etc. So once I got the test ratio, I just now use that 80% here. The depth is there. The criteria is entropy, everything. And I trained a final decision tree classifier, which gave me some results. So the one thing good here is that the drop in train accuracy and test accuracy is not that much. So this means our model has not overfitted. And it's very important that whatever it's tried to learn, it is not in the overfitting regime. And similarly, there are other metrics, the performance on other metrics. So apart from that, for each of the classes also separately, we are printing classification report where there is prediction for each of the classes separately. So the issue here is, the main issue here is that the model is performing not that much good on the one level, the churn thing. We can see that it for no thing, the zero thing, it is performing very good precision, very good recall. For the one thing, for the one whether the person will churn or not, because there are only like the ratio is also different. So ratio is very low, the numbers are very low, so the performance is less. But it's the general trend of this data set. If you will search on internet, there is a like people have a challenge how to improve this. So since we have not used any optimizations, so these are our initial results. And then we
Yeah, just to add here, Ashish, if you will just go back to that. So I think I was talking about there is a uh, input or a parameter called random state, and it can be set to any value. Here it is set to 42. It could be anything like 100 something, 120. The value doesn't matter itself. What is important to note is that if you give a data set, in spite of doing the train test split in a similar fashion and the data being similar, if you do not set random state to some particular value, which is a seed to this, what will happen is that each time you run the same code, you will be getting different results. Different in the sense that not substantially different, but actually number-wise, they'll be slightly different. And as a result, it might become very difficult for you. Suppose, let's say you reported some numbers and then those got changed. So, uh, so in order to get the same results again and again, you can set this random state to some value, any random value. Uh, and then you will be getting consistent result. And the reason for this is that even when the data set is the same, but when we do a train test split of 90-10, there can be n number of ways to do that split. So the random sample drawn of 90% of the data versus the 10% of the data can vary each time for each run. As a result, the performance or whatever you are doing, the experiments will show slightly different values. So it's important to note that if you wish to see the same again, then you need to set this variable also. So that is what I just wanted to add. I think somebody had asked this thing earlier. That's it. You can now continue, Ashish. And then coming to these set of graphs, one thing I wanted to add here. that you can see that we have taken accuracy, precision, decall, F1 score, and AUC. Now, obviously, not all may give similar pattern. For example, you can see that in case of accuracy at 80, they are optimally high. Both values on the training and test are optimally high. They are not highest, they are not lowest. Now, if you look at precision, again at 80, it's optimally high, not the highest, not the lowest. Similarly, if you look at recall, it's so this pattern is continuing. There may be a case when one of these may not be so much high. Like for example, it can happen that if we choose 80-20, it is possible. Say for example, if you look at AUC, AUC is highest at 60, both for training and test data. But it is only AUC that's the highest. And the difference between the AUC at 60 versus 80 is not very different actually. It's slightly different only, but rest of the performance metrics are best optimized at 80. So we are choosing 80-20 as the split. So you cannot satisfy all of these criteria. It may not be necessary, but mostly if they get satisfied, then you choose that particular value. So that is what I wanted to point out here. Ashish, you can take on from there.
So once we had like settled on the our train size, our depth size, so we are using right now entropy as the splitting criteria, and we got these results, the train and test set metrics. And then I tried to visualize this tree. What were the rules that it followed? I think it's a very big image. Let's see how much are you able to see? Uh, so
Yeah, so I
I
think
think
it's okay to see partly also.
so the root node, I think it's visible to all. So it's contract 2 year. The first rule it has applied is the contract thing, that the 2 year, whether it is true or false. And then on the left hand side, it is uses contract 1 year to further split. But on right hand side, it uses monthly charges bill. So that's how it has come to its rule. And there are the depth is still 6, so it is settled at 6. Like these are overlapping. If you increase the size of the figure, you can see that last values also what is written in the last depth. It's not immediately clear what it is written. So this is how we can like visualize that our learned tree also. So and the one-hot encoding comes handy here because everything is now binarized, so we know whether we have to go to true, what we mean by less than 0.5 and greater than 0.5. So similarly, okay, so next we showed some samples. So these are some samples from test set, and I am showing their non-binarized version, their original versions, which were when we loaded them. So these are the ground truth, the original values for them. These are what was predicted. So I've showed few examples, 10 examples from test set, how the performance was there. And same thing we applied now using Guinea as the criteria, and we got the train and test metrics. So the important thing here is that the train accuracy has increased in Guinea. In decision tree, the train accuracy was 79, so it's now 80 in Guinea. But the test accuracy, the main thing is what we are concerned is test accuracy. It is similar to that of Entropius criteria. So we see that for Gini, there is a bit of overfitting. From 80, the drop is to 78. There is a slight bit of overfitting. All the other metrics are more or less similar to that of entropy. And this is how the visualization tree of the Gini will work. And we see that rules are here now different. Internet fiber optic is the first root node. And this finishes the decision tree. And like we can have questions if anyone, if ma'am allows, we can have questions
Yeah,
now.
surely. Any questions, anyone, up to this point? Because we have come to an end of the making of the decision tree with the help of the entropy as well as the Gini index. Now our tree is ready, and then we'll be moving on to random forest. Any questions, anyone so far?
So
Yes,
why we
ma'am.
have taken
Yeah,
six?
Maybe you can raise your hand so that one by one the questions can be taken. Yeah, anyone can start, please.
Ashish, regarding the one hot encoding that we did, right? So based on the data that we have, we don't have a lot of categories. I think that's one of the major reason we have gone for this, right? Like if we have a lot of categories, then it is going to um create multiple
Increase the
columns.
dimensionality. You are right.
Yeah.
If you have a lot of categories, here it is just like yes, no, and all that. And therefore, we are adding instead of one column to two columns. And I think the final number has changed by 8. So initially you had 21, now it is 29
29.
after one hot. Yeah.
Yeah.
Because there are probably 4 attributes that have been added with 2 values each, something like that. But if the number of categories in each of these were very large, then for each a large number of columns would be added, and that would have actually increased the dimensionality substantially, leading to degradation in performance. So yes, we should not use this one hot encoding, not very advisable when the number of values in the categorical attribute is high.
Ma'am, what is the solution to that? Like what else we can use in that case?
Yeah, so I had yesterday explained to you that there are different ways of encoding the data. One is using one hot encoding, the other was integer encoding. So I discussed that in case the number of values in the categorical variables are high, then in that case we should not use one hot encoding for the reasons we discussed, but we can use integer coding, because in integer coding each value is actually represented by an integer, and that's all. We do not increase the number of columns by the number of values. We do not do that. We just replace uh, the categories by numbers. That's how we can handle. That's one way to handle that situation. Is it okay?
And one follow-up last thing. So in this, let's say the category, the optical fiber one, where we have 3 categories: optical fiber, DSL, and no internet. So let's say the train data is having only this, but the test data is having another category as Starlink, let's say. So
Mm-hmm.
this is like both the integer encoding and the one hot encoding is not going to handle that, right? Because here it's
Yes.
going to see a new category, there we are giving some predefined integers, so that is also not going to solve that.
Yes, you're right. So remember, the starting point of building a classifier model is that it should be able to learn all kinds of use cases which it is supposed to predict. So if there is another category, let's say additionally, in addition to fiber optic, DSL, and no, if there has to be a fourth category which needs to be predicted in future, then the training data must be having samples pertaining to that also. And I told you that while discussing classifier, that although we feel that building a classifier is very trivial, it isn't, because it's supposed to have all kinds of use cases which it will be predicting in future. In case it doesn't have, it will fail. It doesn't know what to do. Because this whole process is kind of a static process, right? You are not incrementing the learning at all. Once you fit the model, then the learning of the model or building of the model is complete, and that's it. And then it will be used only to do prediction on whatever it has learned. So you have to be careful that if you do have unseen cases which the model has not learned, then you have to refine the learning itself so that prediction could be done in a better way.
Okay, got it. Thank you.
Yeah, next.
Uh,
Next.
Ma'am, just I had 3 quick questions. To begin with, on the test versus training data set, as the depth increases, we saw that the accuracy of training data set increases, like here. It seems intuitively very correct, but I wanted to check that does it so happen that with tree depth, even the training accuracy would decrease.
So actually, what is happening is when the depth, you just think about it conceptually, that when the depth of the tree is increasing, it means that we are actually using more and more out of those 20 attributes. Like one was the classifying attribute, there were 20 other attributes, right? So as the depth of the tree is increasing, we are using more and more attributes from the training data, and we are using them to build the classifier model. Now, what will happen is that when we use more attributes, the accuracy is likely or the performance is likely to increase only. It will not decrease, especially on the training data. However, this increase is actually, I should say, it's a gimmick or a pseudo increase, because though it's looking like the accuracy is increasing, but using more number of attributes than what is optimal will only, make the model overfit and make it very specific to, the training data only. And as you can see here, that if we were to use the test data at that point where the training accuracy is higher, the test accuracy you can see is much, much lower and it is underperforming. So, but definitely as you increase the number of attributes, the tree depth increases, and as the tree depth increases, the training accuracy will not go low, it will increase only, because you are giving it more and more data to learn. So therefore, learning is becoming better, and therefore the accuracy is going higher. It will go high only. Okay, it will not go low,
That
especially for the training data.
That makes sense, ma'am. So, a related question, the second one I had was that in the 80-20 rule that we have, I've worked with ML engineers who always take 80-20, and now I understand why they do that. But as 80 increases to, say, 90, in certain cases, let's say, hypothetically, accuracy, precision, recall, all of that increases. But it seems that we still shouldn't take it because if the training data set is large, we might not be able to see correct results in the above graph. Uh, wouldn't it restrict our view of what should be the correct depth of the actual data set that we should take if the data set is way too small, say just 10% of total data?
What you're saying is that if you take 90-10 as the split ratio, then our test data is going to be quite small. Is that what you wanted to ask?
Yeah, yes, and wouldn't that impact the graph above that we saw, where we are getting right now a depth of 6, maybe we'll get a depth of 7 or 8 incorrectly. Would that basically, are these two things related, the volume of test data and the correct depth that we'll get?
Yeah, yes, definitely. Actually, they definitely are related to some extent. That you see that if we are taking a large volume of the data as the training data, right, and a lesser amount as the test data, then what will happen is that because the volume is high, therefore lesser depth may suffice to to train the model, right? And as you rightly said, that if you actually decrease the volume of the data, then more depth may be required to achieve similar precision, recall, accuracy, and all that. So they are definitely required. Also, because most of the data, let's say if we talk about 90-10, then less depth would suffice, and the learning is quite complete. However, the generalization would suffer. That also would be there, and therefore the test accuracies or the accuracy or the performance on the test data might be substantially lower. So you are right in saying that the volume of the data definitely impacts um, the depth of the tree as well as the performance that can be achieved. Because if most volume of the data is chosen as training data, then training error or accuracy, precision, recall, etc. on training data will be high, and that on test data will be low. At the same time, a less depth of the tree would be required to achieve these. However, if the data was less, then more number of attributes will be required. So you're right on that actually. And it's
Thanks, ma'am.
quite interesting. You can give it a try also, and just try to vary it. So
like
here, yeah, so here actually you can vary it right now,
to point
Ashish.
to, like you
Yeah,
can
yeah.
vary it to point to and see if the depth is different. Initially, which we have set to
Understood.
point one.
Yeah.
Indeed,
So,
Ashish. And sorry, ma'am.
so if you do a 0.2 to 8, probably it might come to something around 7 to 9, something between that. Yes, please continue.
Thanks, ma'am. Ma'am, one final question was that a depth of 6 might mean, and please correct me if I'm wrong, it might mean that we are not using all the attributes, and
Yeah.
maybe at the depth of 6. So, is it more optimal that if we are taking a depth of 6, we ask the model to remove the other attributes completely, and for all the production data sets, we use only that number of attributes. Is that something that we also would do?
Uh, so I think just by looking at this and using this to remove the attribute may be not a good solution. Uh, a better solution would be that if you want to remove some of the attributes, I would suggest, and I think we can add it here also probably for. So what you can do is do a heat map and try to see the correlation amongst the attributes and the correlation of the attributes that are there versus the class variable also. So what you will see is some of the attributes may be behaving in a similar fashion and you can do away with them, number one. Then secondly, those which are very much correlated positively or negatively with the class label, you must definitely retain them. Also, if you are very confident that the tree that you have drawn is good enough, then you can have a look at the attributes that are on the higher 6 levels or the levels, number of levels. Let's say if you grew the tree more than the depth of 6, let's say 6 was the optimal depth and I grew it till 10, then also I can identify which are the ones that are higher up and those may be the most significant ones, right? And if you remember, while feature selection, I had showed that a decision tree is a very useful way to decide which of the features are more useful and to do away with the rest of them. That can be one thing, but you need to be sure that the decision tree is correctly done. Otherwise, you'll end up losing information. And therefore, I say that to, especially in case you are doing it in production, then you should also try to ensure this by other methods such as heat map and all that we discussed in ETA part. It can be added here also. Uh, and then you can find out which ones are comparatively redundant and you can remove. Okay.
Thanks, ma'am. And it's quite what I can understand from all this process is that the value of depth is what we are trying to achieve correctly to get
Yes.
the model as good as possible, as accurate as possible. I mean, all the values help us determine what should be our depth, and at that depth we will go ahead.
Yes, that's correct. That's correct.
Thank you, ma'am. That's all from me.
Yeah. Any other questions? Any?
Ma'am, so my question is,
Uh, my name is Kadravan. I have a question here, madam. Question
I
is,
think just one second. There was a order in raising of hands, so I am not able to get it, but probably Simran can help and we can go in that order, please, right? So
Venkat, you can.
so my question is, there are uh, two ways of overfitting here, right? Like one is based on the depth of the tree, so that we have limited based on our analysis. And one more thing is it can also happen through the uh, over like based on the train test split, which is if we take like 90-10, even that is kind of like overfitting only, right?
That's not exactly overfitting, but 90-10 can have an impact on the depth of the tree. See, we are not going to overfit just by taking 90-10, but if we take 90-10, then the depth of the tree might reduce because we are having a large volume of data as the training data only. So that split does not lead to overfitting. But there are other after effects that can lead to overfitting. That is what I wanted to say.
Okay,
Is it okay?
yes. And one more thing is like regarding the interpretability of the decision tree model if we have multiple categorical values. So my doubt is we can do the integer encoding, and then even if we get less than 1.5, it means two categories put together in a node, and that node will have the class level impurity based on the gene index or yeah, here it means like less than zero point 0.5 is 0 and greater than zero point 0.5 is 1. So if we get
Mm-hmm.
1.5 also,
Mm-hmm.
we will be able to interpret it such a way that two categories are in a node. And
Yeah.
maybe down the line other there will be one more split like less than zero point 0.5, which will further divide those categories into each category in each node.
Yeah, I mean, of course, but only thing is, what you're saying is correct that though it can do a split on 1.5, and if it does so, that let's say if we are having three categories, 0, 1, and 2, then 0, 1 go together and 2 goes separately. But only thing is 1.5 in itself doesn't have any meaning, right? So it doesn't look like a logical split because something, if you are having categories called 0, 1, 2, and 3 or 0, 1, and 2, then 1.5 is nothing. It's no category at all. So
But
that, yeah.
even here, if we see like contract
Mm.
2 year less than zero point 0.5, streaming movie is less than zero point 0.5, everything like it is splitting based, if it is 0 and 1, it is splitting based on zero point 0.5, right? So
Mm.
even if we can get 1.5, it means 0 and 1 together and 2 as a separate.
Yeah, yes, yes. What you are saying is correct technically, that 1.5 split on this would mean 0 and 1 together and 2 in a separate category. We are having 0, 1, and 2. That's correct.
Okay. And one more thing is in the precision and recall, all these metrics are they correspond to a model, right? Like uh, we take in the confusion matrix, we take the positive and negative and their predictions, so it is corresponding to a model. uh,
Correct.
so
Yes. So we have
in
fit a
the
model previously.
Yes, ma'am. So,
Uh,
Ashish, I am referring to the output, the values here, 0 and 1 precision recall. So, why are we showing here for 0 precision recall and also for 1? These are like class labels, right? We are showing class level precision recalls, but this will be for model level, right?
So for model, overall precision is this. But if we just focus on the true positive of the zeroth class, or if we just focus on the true positive of the oneth class, we are showing individual class level precisions also.
Okay, okay.
uh,
So
so
this is
I
like,
want
If
to,
true positive comes from both 0 and 1, sorry, true positive is for 0, for 1 and 2 negative or that for 1. So for individual ones, we are also showing. So just to show the difference that the lower value, it's because of the 1th class.
okay, so you mean like when we take 0 as the positive, so what is the
Yeah.
precision recall in that case? Okay, okay, got it.
so I just want to add here, it's extremely important actually to have the breakup as well. Let's say I'm interested in churning only. I'm not interested in no churn. So I'm interested in, predicting churning only, mainly churning only. Then I must have a model which is having precision, recall, F1 score, everything high for my churn class, right? Because no churning is not that very important. Let's say, for example, there's a situation. So in certain cases, certain class value is of more importance than the other. And we actually want to know what is the performance of the model for that particular class. Therefore, it's extremely important to have all these performances at the class level also, and plus you have the overall performance of the model, which is sum total or averaged on all the classes. So in case you are having both class of equal importance or of equal interest, then you look at the overall matrix. Okay.
Ma'am, but when we are looking from here, one is churn, right? When we are looking from the churn's perspective, it is positive, and non-churn becomes negative. So here already we are at like there is precision and recall, there is also sensitivity and specificity, right? So will it uh, will it not be complementary, like wherever there is specificity it would be like a precision in the opposite case, wouldn't it
No,
be
no,
like?
you are right. But what point I want to make is, see, you see the overall precision of the model. I think Ashish, you can highlight is 0.612, right? This is the overall precision, irrespective of the class. But if you look at the precision of the respective classes, the precision of the model for the zeroth class is coming out to be 0.83. Ashish, please highlight that, right? And the precision for class 1 is 0.61, right? So definitely the overall precision is getting impacted by the class 1. That is one thing. But if I want to have a model, which is giving me a certain amount of precision, I want a certain amount precision to be minimum for the churn class, then I'll actually have to look at the precision for the churn class also, right? The overall precision which we are getting may or may not be the same as for the respective classes, which you can very clearly see here. For the zeroth class, which is a no churn, it is like 83%, but for the churn class, it is 61% only. So the point I wanted to make is that overall precision is good. We want to see how the model is performing irrespective of whatever class you pick up. But in some cases, you want the breakup also on a class-wise basis, because you may be interested in some specific class, and hence that breakup is also shown here.
Yes, we got it. Usually we take one for the category we are interested in and consider it as positive, but yeah, if we have to give both of them preference, we can check both.
I think you are right in that if we had more classes here, we right now have only two classes. It would have been more meaningful if there had been like three classes, 0, 1, and 2. Right
Yeah.
now, the precision here 612. It's for the true positive class. It's for the positive class 1, and it's the same values here. So you are right in saying that they are redundant right now. But as ma'am said, we wanted to look the for the 0th class also. So that's why we did this.
Okay, got it. So I think I just have to explore even specificity and the sensitivity where, like,
So
where I'm
recall,
thinking, yeah.
yeah, recall is same as sensitivity.
Yeah, sensitivity is same as recall.
Okay.
You can just look at specificity, which is the FNR or the false negative weight. You can additionally explore that also. Okay.
Okay.
Yeah. Next, please. Any other questions? Okay. If there are no
Yeah.
further
No,
questions,
ma'am,
yeah,
actually
you
there are.
have.
So,
Okay.
ma'am, one question is, so as we consider depth of 6, which is giving us the most optimal result, right? But there must be some sequence of fields which decision tree has concluded. But is there a way we have control over like what fields to give more priority as compared to others? Bec-
So you are talking about some kind of weights being given to some
Yes.
attributes.
Yes.
Ashish, will you want to take up? I think probably the function, will it allow some weights? I do not recollect right now.
No,
If
right
there
now I
are
don't
any.
think it will allow any like giving weights. We'll have to like see if scale.
We can just see whether that will be possible. But what you can do, I know, even if the function cannot give weights. Okay, let's have a look at the function itself.
Like it's having like for class you can give weighted for weight, like because one class is minority, you can weight it more. But I don't think that it's allowing to give weight to
Yeah.
input features.
So class weight is the classifier, like what we are classifying, right? 1 and 0, like my target variable. That should be the class.
Yes,
The only
yes,
point is that
exactly.
if you are saying like being a domain expert, I feel like this field is one of the deciding factor for any churn or something.
Like
And I
if
want to
recall
make
is
sure.
like recall is more important to you, so you weight the one class more. So we want the model to show me the more important thing is me the people who have churned. So I will weight the class level one as more. So so we'll give a list of values. It is showing here.
I think
You
he's
give a
asking. I think he's asking a different question. He's asking,
Yeah, so I'll address that. I think you can go back again on it, Ashish. So you want to give more weight to certain attributes. Say, for example, as you mentioned that you are a domain expert, you know that's more important. So the only best way to do it is to add that weights while pre-processing, because it cannot be done in the function. There is no placeholder for incorporating weights for the attributes. Okay. So what I suggest is that when you are actually pre-processing, then you'll have to incorporate the weights before handling the data. Say, for example, let's say that you want to give some more weight to certain attribute, certain some particular attribute, then probably you might have a dummy column, giving some weights to each of the attributes and consider that as an additional attribute. Something like that you can do.
But
Like
still,
that could
yeah,
be.
yeah. Still, I won't have that control. Like in the first
Yeah.
6 fields, that field
Hmm.
is being considered or not. I
Yeah,
won't
yeah.
have that.
You will not have the control on which six will go as the first six attributes. Yes,
Okay.
that control will not be there with you. Only thing is that based on your domain expertise, and if you know that certain attributes are more important, probably you could have a weighting column. I mean, you could have some extra attribute being defined, and that assigns some weight, and that could be considered. Probably we'll have to actually think more about it. There should be a way possible to, somehow give some weights, and based on that weight, only the attribute will be chosen in that order of the weights. That's what you want to say, right? If you
Yes.
know
Yes.
some kind of ordering can be enforced, then the attributes that can be chosen would be first. Okay, one thing I want to say here is that if you want to enforce a ordering on the way in which the attributes are chosen in the tree, then you are actually not drawing a tree, right? In a decision tree, you are choosing the attributes in a way, in that particular fashion, in which the entropy is, deciding. Let's say if there's one particular attribute, say number of dependents, yes, and this is the one that is giving the best entropy gain, information gain based on entropy, then it will choose that one to do the first split, right? And accordingly, with the rest of the attributes, it will go for the second split, third split, and so on till the total depth, say in this case 6. But in your case, you want to enforce certain attributes to be used first. In that case, you don't need to draw a decision tree. All you need to have is kind of a rule-based splitting. So you know that you want to choose first attribute as certain attribute, say X. You choose that, and on the basis of, you decide a rule. Okay, this such value goes towards this side, and the other goes towards that side. So actually, in a way, you are just choosing the attributes, and you are doing some split, and you can actually convert any set of branches, as I told you, in a rule. So in a way, you are not doing a decision tree there, you are defining certain rules and using certain set of attributes, and you can use those rules for for growing the tree. for classifying the data. So then decision tree will not be required there. That's what I wanted to tell you. That if you know the attributes you want to use and you want to restrict to that only, there's no point growing the tree, right? Because in the tree, we decide which attribute to use best, and that is the one that is used first, then second, then third, like that. Actually, in your case, what will be required is a rule-based classifier, and I'll be discussing that also. So probably your question that you wanted to, enforce usage of certain attributes, that will be answered at that point in time.
Okay.
Ma'am Ashish, here.
Mhm.
I'll go next. So my question is that we have used decision tree classifier and we saw the graph. When is it actually going good with the depth? So did it actually create the tree, then evaluated the training data and test data, and then it evaluated how many correctly predicted? So it was so much computation to do, or I am getting it wrong?
No, you are completely right. To only, decide even a split ratio, you have to actually do all the combinations. Please come to the graph, Ashish. Uh, so you can see here, to decide which particular depth to go or which split ratio to use later on, you have to do all those computations. And in this case, luckily, this stops at around 2930, because beyond that, we are reaching a plateau. But if your data was much more complex, this value of the tree depth and the number of attributes will be larger. It will be still much more. So you are correct that to even decide one thing, you have to do all those computations. That's correct.
So we have like used the loop here. We are looping for every
So
and iterating for each of the depth and creating a decision tree, storing the training values, the testing accuracy, and then after plotting it. So yes, we are doing it for each depth.
so if let's say millions of rows are there, we took a sample out of it, and on that sample we divided into training and test, and then we will do this. That's how people do it generally. Otherwise, it will be very difficult to do it on top of the entire data, right? I'm just
So
asking.
yeah, so Ashish, the answer to your question, there is no straightforward answer to it. There can be multiple ways. It can be true that you take a stratified sample. A stratified sample is one which contains, proportionate amount of samples in each of the category as compared to the original data, and you do the performance analysis on that, and then arrive at some particular values for the parameters and use them to do the full tree. That is one way. You are right. Another way is, if you have compute, then do all this and then arrive at the correct values and then go ahead and do the tree. It all depends on the application, right? If you are okay to approximately use broadly correct values, you do a stratified sample and use it. If you have compute power and you are interested very precisely in the performance of the model, then you have to do it on the entire data.
Okay, and ma'am, the next question is uh, the heterogeneous classifiers should be picked first as the as the gain says. So that is the order in which we picked the nodes in the tree that we are creating. Am I getting it correct? Because so many nodes are there, it has to calculate for every node, and then it has to decide which one will come on the top. A lot of permutation combination there as well.
So yeah, so what it has to do is that, as we discussed in theory lecture,
Mhm.
that to decide which attribute to use, it will have to first go ahead and calculate the information gain for each and every attribute that is available at that point in the tree. At the root node, all 21 or whatever 28 variables will be available, and it has to do the information gain calculation for each one of them and then choose the best one. And to do that, it can use entropy or Gini. So that's a hell lot of compute. Then at the next level, again, this is repeated and it goes on repeating. So you are correct in that way that it does do all that.
Yeah. Okay. Thank you, ma'am. Thank you.
Okay, thanks. Next, please. Anyone else for the questions? Or shall we move on quickly because also we are running out of time? Shall we move to the random forest? I think there are no questions. So Ashish, probably you can start discussing the random forest part.
Okay, so after finishing decision tree, we are now moving to random forest, and we are working on the same data set. But the parameters to consider, the hyperparameters to consider are a bit different now. So in random forest, there are two main hyperparameters to consider. One is in sklearn, they call it an estimator, which is the number of trees. So how many the forest will consider of how many trees. So it will be a number 50, 100, 75, etc. and max features. So so what random forest does it at each split, it randomly selects a subset of features. So how many features you want to select? Do you want to select from all the 29 features or some less features? So these are the two main hyperparameters we are trying to tune on, and then after tuning we will do we'll train a random forest classifier on the values we get. So first we do for first we select the optimal number of trees, and we selected in the range 50, 75, 100, 150, and these can be increased further also, but to show with less computation and so the code runs quickly, we show only for these four values. And we run random forest for each by looping through all of these values, 50, 75, 100, 150. And this is how, similarly like decision tree, this is how all the metrics performance looks. So here also there is no one best estimator which works for all, but overall for 150 there is a like 150 it peaks for recall and F1, and on AUC also it's slightly down on AUC, like it was like dysentery was there, similar to dysentery. And for accuracy and all, it shows second highest. For precision also, it's giving slightly less performance, but we settle for 150 because at least it's peaking on two values, and for all others it's a comparable performance. Similarly, we could have tried on 80 or 100. I used this because when I tried on the other values, it was showing less results in the final model. So like that's why I settled for 150 estimators. Similarly, now after fixing the estimators, we'll see how to select the optimal number of max features. So we've looped the random forest classifier in the range 5, 10, 15 till 29 is the maximum number of features we have. And then we again see the graph. Just a minute. Okay, so this is how the graph looks. So we see that for accuracy and precision, 29 features, for accuracy, the best test accuracy is on 29 features. But recall and F1, they again peak at 15. The AUC value is lower, it declines at 29, and it's moderate, it has a moderate value at 15. And precision also, there's a decline, but to settle on one of these, because like 29 features is too much, and 10 is less of a feature. So to balance it out, and since 15 was like peaking on two of them and showing comparable performance on other, we settled on 15 as the max features. Once we have decided on what will be our max features, what will be our number of estimators, we again run the random forest classifier. So this also is run twice, one for the criteria entropy, because internally in random forest also, like we are having 150 150 trees. So these are decision trees, and each of them will be split based on some criteria. So first we have tried on entropy, and next we tried on Gini, the same thing. So these are the results. So there is I think around 1% increase in the accuracy as compared to decision tree. If it is had been an ideal data set, we would have seen a much larger increase. But right now, the increase is around 1% only in all of the metrics, or maybe comparable. But overall, this is a table showing all the all the metrics that we got from decision tree and random forest, and we can see that random forest at least performs like it performs better than alone decision tree for this data set. So
So
that finishes the code.
yeah, so we pretty much discussed the building of the tree and then using the same data to build a random forest and then do a comparative analysis on which one is the best and which particular criteria, entropy or Gini to uh, use. So now open for questions. I could see something on the chat. Can you just speak it out?
Yeah, so I wanted to know like the depth of these 150 different trees. Would it be like same or like variable?
Like we settled for 6, we could have because we got that number from previous. We can try. I tried some other depth also, 10 or like less than 6, like 4 and all. But the like best performance was on 6, around 6 only.
So like all 150 trees would be of depth 6.
Of depth 6. Yeah, all
So like
150 will be of depth 6.
like is there a mathematical concept behind this, like keeping the depth of all the trees same gives a better result? I don't want the proof, I just want to know like if is it
So I think it has more to do with how the random forest classifier has been pre-coded. So if you try to look up the pre-coded function in the library, it requires certain hyperparameters, and once given, these are fixed for building that model. So you have the number of estimators, which is the number of trees. You have the depth pre-specified, then you have the number of attributes and all that stuff. So this is the way the random forest uh, actually the random forest function works. So these are some of the hyperparameters. So you define depth, you define number of features, which is another parameter. You define which criteria, whether entropy, Gini and all, which one to use and all that thing. So therefore, I don't think that there is any mathematical reason to go for the same depth or something like that. But usually all the trees in the forest, they have the same depth, they have the same number of samples, and therefore we use bagging for that purpose. They also have the same criteria, so you cannot have a forest in which out of some trees will be using entropy, others Gini. That's not the way it is. So it is usually common to all the trees, all these things, and this is how it is also quoted in that function. I think you have pulled up that function also, Ashish. You wanted to show that?
So like this is the type function here, and so the max depth is set for all the trees. So the algorithm in the logic of the random forest, so we keep the tree depth fixed for all. The randomness comes from that each of the tree is shown a random subset of the data with replacement. So the randomness comes from there, but the depth is same for all the trees.
so this is the max depth, right? It is not necessary that all
Yeah,
the branches would be of depth 6, let's say. Some of the branches can end maybe at 3 or 4 also, right?
yeah, it can.
Okay, got it. Yeah, thanks.
And how
Yeah.
does
I think,
how
sorry to interrupt. I think what you are saying is correct. We should actually not say it as depth. We should say that max depth, and it is written max depth also here. And just for convenience, we are calling it depth. It is max depth, which is 6. Yes, please. Ashish, for you.
I
Sorry.
was asking in the random forest, So in the decision tree, we created one tree, but here we created so many. And for a no, I just want to imagine that part. I know you told earlier, but if I have, let's say, created 150 trees, and do we average something here, like which node is best at a place out of?
So
Mhm. Can you?
averaging is done on the performance of the random forest. So see, when you are having 150 trees, actually, if you take individual performance, then it will give 150 set of performance parameter values.
Mhm.
But what you are getting is a single value because that is averaged on the total number of trees in the forest. But other than that, nothing is averaged out. Only these parameters are set to the values that we have inputted, uh, as you can see here for the classifier like depth and all. Uh, and that's it. And then the choice of the number of samples is purely random, and the number of attributes.
It's also
Uh,
random.
yeah, so once having decided on what will be the total number of attributes is going to use per tree, what what set is going to pick, that is its choice. So if I have to use, let's say, 6 attributes or 10 attributes out of 28 attributes, then which 10 those are going to be, that is just decided randomly. And that's not a fixed at all. But the
Okay.
number is fixed.
But
So like ma'am,
we gave here entropy as a criteria. Oh, that is for the, that is which one will come first. But you are saying
Yes.
the features will be random. Okay, I get it.
Mm. Okay.
so
Anyone
like
else? Or
ma'am, like I want to
yes, yes.
clarify, like you said, so randomness comes from two things, like one from the number of attributes which will be shown. It will be shown 15 random attributes at each split, and from the samples which will be shown to each tree. Is this
Hmm.
the randomness in random forest classifier? Is this how?
Number of samples and number of feature random, right?
Yes, yes. Correct.
Um, Hello, ma'am, and Ashish, just trying to clarify my understanding here on the fundamentals of the things that we have learned today. So, the decision tree and random forest, these are all like the supervised learning algorithms. So we can say that. And what
Correct.
is in the end that random forest gave us the a better result or something which is much more correct in that way. But as I understand, I think random forest is also dependent on your decision tree. We cannot consider them to be separate and just go with random forest kind of calculations without having decision tree. Is that correct?
Uh, so, what was the last part you said that we cannot
No.
go with?
Yeah. Like what I'm trying to say is, can we consider random forest separately without having decision tree? I don't think that is
Mhm.
possible, right? Decision tree is an integral
Y-
part of random forest. Is that correct?
Yeah, yeah, yeah. It's correct because random forest is an ensemble of trees.
Hmm.
And
So you
ultimately one
cannot,
is picked. Ultimately one of them is picked, is if I'm getting it right.
what is it? One of them?
So if randomly we created 150, so many trees, so many decision
Yeah,
trees.
so
Hmm.
actually, if you think of random forest as a building, then the bricks are the trees. So you
Right.
cannot build a random forest without the bricks, or you cannot build a house without bricks, right? So if you talk about random forest, trees in it have to be there. You cannot have a random forest and have some other form of classifier as the building block. No, you can't do that.
Okay. But ma'am, so is there any scenario where we would stop at decision tree for a result, or we always have to, go ahead and create the random forest calculation, do that, and then arrive at a at a conclusion always? Is that the way we do it, or we can also stop at a decision tree calculation?
Yeah, yeah, yeah. You can stop at the decision tree.
Hmm.
Let's say that whatever performance you are getting with the decision tree and you
Hmm.
are satisfied with that much, then it's okay not to go ahead and try the random forest. That's
Yeah.
purely up to what you want to do and how you want the results to be. There may be other classifiers also which you will study, and then sometime down the line, you may have decision tree, random forest, you might have others also. So
Hmm.
again, it's purely going to depend on what and how you want to do. Then you will choose the classifiers accordingly.
And ma'am,
Yeah.
ma'am, just last doubt. I know it's a silly question, but suppose we 150 trees, and via this process of creating random forest trees, finally, do we pick one of them which is best giving us result, or
No,
okay,
no,
then
we don't do that. Forest, always remember, the name is random forest. So forest is a group of trees. You
Mhm.
cannot pick up one tree out of the forest and say this is giving me the best one, because if you do that, then you are doing a decision tree.
Mhm.
So if you use random forest, then it's going to be a forest only. And that forest is nothing but a set of trees. It cannot be one tree. You cannot say, even in the real world, I saw a forest where there was only one tree, right? It won't be like that. A
So
forest needs to be a set of trees only.
so is it like instead of nodes, we have some trees to decide something whether we go right or left in a decision?
No, no, not like that. Because in a decision tree, the nodes you have will still are going to be there still. I actually had shown you a diagram in which I showed you how bagging works. So you think of it as 150 trees in parallel. Okay.
Mhm, mhm,
You have a data set, you
mhm,
draw random samples,
mhm,
and you draw this random set of attributes based on whatever numbers we decide.
mhm,
Draw all those 150 trees, in this case it is 150 parallelly,
mhm.
and then after the parallel trees are done, average out on the performance metric, and you get the aggregated performance of the random forest. This is how you do it.
Mm.
And each tree will have nodes, which are looking like the nodes that you are seeing here in this figure.
Okay,
Okay.
so average of the final answer is something that will decide, right? If I
So the
get it now. Okay.
average of let's say 150 trees, you will actually, each tree will give some precision, some recall, some accuracy in all that. So your final performance of the random forest will be aggregating the results of the individual parallelly running trees in that forest. Okay, so
Okay.
that is
Okay.
how it happens.
So if let's say 76 out of 150 trees, if 70 are saying that it's a yes, and let's say churn is yes, and rest
Mhm.
are saying no. So we'll be finally averaging out that mostly are saying it's a yes. So or
Yes.
yeah, is that's how it will be, right?
Correct, correct. That's
Okay.
correct.
Okay. Okay.
And we do this for all the samples, right? Let's say we have some 7,500 samples. We do this for all the samples. And then based on the correctness of these yeses and nos, we decide how many true positives are coming as true positives and true negatives as true negative. And then we calculate the overall accuracy of the tree. Similarly, we calculate the other parameters, just like you have mentioned, and then we find out the overall performance of the tree.
Okay. Thank you, ma'am. That answers my question.
Yeah. Next,
Hi,
please.
ma'am. Sakshi this side. So my question is regarding the max features. So I understood that we are deciding the max features using precision and recall, but the initial list that we took, how is that being made? Is there any calculation or is it some random list that we usually make, like where we were keeping it like
Which
5,
list
10,
are you
15,
talking about? Which
where
list
we
I could not get?
started with the range
Oh,
like 5,
yeah.
10,
No,
15?
no. This is just we thought that we'll vary it over these values. Okay. So these are
No.
the total number of features. So in our data set, we have like total 29 attributes, including the classifying attribute. So we went up to the max range and we wanted to start out a little lower. We started with 5. However, obviously, you will have some X number of attributes available with you. So you can actually, ideally, it should be varied over each and every
Yeah,
increment, like
that
5,
because
6,
like
7.
we did
Yeah.
with depth, we looped all, for all the values
Yeah.
and then decided.
Yes,
So
yes.
similarly, we can
Yes,
do that.
yes.
Okay.
Yes, yes. Just to save compute power and all, we just took some intermediate values. Ideally, it should be all.
So like in library, they have given some options for what should be max number of features. So I give an option like you take the square root of the total number of features, you take the log of the total number of features. So and that they are saying that the default the library takes the square root of the total number of features if we don't specify anything.
Okay. Okay, thanks.
Next, please.
Ma'am, here we are using the random forest. So random forest, we have two methods, bagging and boosting. Which currently we are using here, because we are using all random forest your library that default what feature actually it used.
Ashish, can you please take?
I
I'm
think
just getting a call.
random forest is like boosting is separate thing. Random forest is bagging only. Bagging means bootstrap and aggregation. So by bootstrapping, we mean we are taking random subsets with replacement. For each tree, there is a random subset of the total data with and these are for other tree there is another random subset but with replacement, and then we aggregate the results. So it's bagging. Random forest is bagging. There are other techniques like ADA boost, and other boosting techniques which we have not discussed yet. So boosting is separate thing.
Is
So
it
all these
okay?
are all these are come under ensemble methods. Random forest is bagging, and boosting is separate thing which we have not discussed yet.
So
Okay.
I had discussed the concept of bagging and boosting, and then choosing bagging. We discussed this random forest. So boosting we'll discuss, I mean the use of boosting in classification we'll discuss slightly later in some other classifiers. Okay.
Okay.
Yeah. Okay. Next, please.
Ma'am, when we say random sampling with replacement, is there a chance that some of the data points or samples cannot be picked up by any of the sample because some
Yeah,
of them is
yeah, what you're saying is exactly what can happen. I showed that with a diagram also. If you attended a class, that because we are having replacement, there is a possibility that some of the samples might never be picked. There is also a possibility that some of the samples might be picked multiple times in one particular subset. There is a possibility that some set of samples are picked. All that can happen, but the possibility of any particular sample not getting picked at all is actually kind of neutralized when we have a large number of trees in the random forest. If we have a smaller number, then this probability of not choosing any particular sample at all is quite high. But if the total number of trees in the random forest is quite huge, then the probability of it never getting picked reduces substantially.
Yes, ma'am. Yes, got it.
Okay, next, please. So, any other questions, anyone on whatever we have done so far? So, if there are no questions, then I think Ashish, you can do a stop share. And I think many of you had discussed that you want to try out some assignment. So, it's only an optional assignment that I'm telling you verbally. Uh, that we saw that we chose a depth of 6, and initially to decide that we had taken a split of 90s to 10. So what I'm suggesting to you is initially try all the splits, and so instead of first choosing a split and deciding it to go to the depth, you initially itself, you let's say you try different permutations of the split ratio versus the depth, and then arrive at the most optimal one. So you try the code out for that, and then what is your performance, you see whether it's going to be better or worse than what you are getting currently. So I'll repeat the question. What I'm saying is initially in our code that I gave you, we first chose a split like 90-10. Based on that split, we decided what depth we should go to. That came out to be 6. But instead of doing that, let's say that you choose all possible combinations like 60-40, 70-30, 80-20, 90-10. These are the 4 combinations that you can try. And for each of this, you find out what is the most optimal depth. 90-10, you already know it is 6. But for others, you find it out. And then using that particular depth, and the split ratio, corresponding respective split ratio, you build the trees and then look at the comparative of the performance and see which one is the best. Okay, this is an assignment that you can try as a self study, just to explore and see how best to utilize a tree and random forest. If you have questions on anything that I'm saying, you can ask me right now. But it is not graded or anything. It is just for those who are curious to know how it will perform. Is it okay, everyone? Then shall we break for today?
Yeah, thank you, ma'am.
Yeah, thank you, ma'am. Thank you, Ashish.
Ma'am,
Thank
Vikas,
you.
one question I have.
Thank you.
Thank you,
So
ma'am.
during these assignments and while we are doing a code testing, if we have to take some help, what is the process? Can we get in touch with Ashish, or how exactly this is going to happen?
So I think for that you'll have to, because we Python coding, is not part of the course actually. So we are more interested to the course sits on the Python programming skills. So I think you are having some extra classes in which Python is being taken. So possibly you can get in touch with the instructor and ask if you are having some specific coding concerns, because I think those classes are already scheduled. You can request some things there.
Okay, ma'am. Thank you.
Okay. Okay, then thank you all. Have a nice weekend. Thank you. Bye bye.
Thank you,
Thank you,
ma'am.
ma'am. Thanks a lot.